Hi everyone. Today let's talk about session 7.4, Test of Hypotheses. Okay, so in this session, I will talk a lot. So I really hope that you can pay 100% attention while I'm talking. Okay, when you have questions, don't forget you can print screen and ask me. So our goal is to decide whether a statement concerning a parameter is true or false. Example 1. The manufacturer claims that the average drying time of its new fast-drying paint is 20 minutes, and the Consumer Protection Agency wants to test this. A staff will paint 36 boards using different cans of the paint, and with the intention of rejecting the claim if the sample mean of his 36 boards, okay, the time will exceed 20.75 minutes. Assuming from past experience that the population standard deviation is 2.4 minutes. Find part A, the probability of the sample mean greater than 20.75, but our population mean is 20. Part B, find the probability of the sample mean is less than or equal to 20.75, but our mean, population mean, is 21. Okay, what are those? What does this mean? Okay, so we paint 36 boards, and this guy, see, okay, so here, this is the criterion when we reject the claim. Okay, so this is the criterion. When we reject the claim, if we get the sample mean exceeds 20.75, because he claimed that it's 20, so this is our criterion. So you can also make the criterion to be maybe exceed 20.5, we can reject it. Okay, so you can make a criterion. And okay, so let's look at part A. What does that mean? Well, the sample mean greater than 20.75. Do you accept the claim or you reject the claim? Well, because it exceeds 20.75, so this means we reject the claim. Okay, but the population mean is 20. What does that mean? Well, we reject the claim, but the claim is true, right? So this is a bad decision, right? This is a bad decision because the claim is true, but we reject it. What is part B? Well, X bar less than or equal to 20.75, which means we accept the claim. Okay, but the population mean is 21, so the claim is false. Okay, so we accept the claim, but the claim is actually false. So this is also a bad decision. Okay, so what are all the possibilities here? I make it into a table. Okay, let's say we have the population as we have the manufacturer's claim. Okay, so H is like the manufacturer's claim. Okay, the claim can be true or false. Okay, and our decision, we can either accept the claim or we reject the claim. If the claim is true and we accept it, well, that's a correct decision. Okay, but if the claim is false, we accept it. Well, this is a bad decision. Okay, if the claim is true and we reject it, this is also a bad decision. If the claim is false, we reject it. Well, this is a correct decision. You can see this guy and this guy, they are also bad decision, but they are different. So this guy, if the claim is true, but we reject it, this we call type 1 error. If the claim is false, but we accept it, then we call it type 2 error. So let alpha be the probability of type 1 error, and let beta be the probability of type 2 error. Okay, so here in our example, Part A. Part A is the claim is true, but we reject it. So this probability is actually the probability of type 1 error. So that is alpha. And part B, the claim is false, but we accept it. So this is actually a type 2 error. That is beta. So far, so good, everybody? Okay, solution. Okay, so remember in chapter 6, we have the central limits theorem. Okay, so we have the sample mean is approximately normal. That means the standardized sample mean is approximated by the standard normal distribution. So here, because we have 36 boards, so n is greater than 30, so that's large sample. So that's why we use standard normal distribution z to calculate it. If we have a small sample, then we use t to calculate. Okay, so here we assume the population mean is 20, and then the population standard deviation is 2.4, and n is 30. And then the probability of our sample mean greater than 20.75, what do? We subtract mu, which is 20, over sigma, which is 2.4, over square root of n, which is square root of 36. So if we do this thing to this operation to the x bar, we also need to do the same thing to the right hand side, 20.75. Okay, so this guy is z. So that's why here we calculated in our calculator, we get that number is 1.875. Okay, so that is greater than. For standard normal distribution, we use the table 3, the CDF values for it to calculate. For the CDF values, we need to see less than equal. So when we have greater than, we use 1 minus probability of z less than equal to 1.875. Okay, so that is the same as 1 minus the CDF values at 1.875, and then we can find it in our table, and then we get the number 0.9696. So this is table 3. Okay. Or sometimes you remember your table 3 only covered 2 decimal places. So if you want to have like more accurate numbers, if you have like 3 decimal places, you can use some online stat calculator, which I gave you a website before. You can plug in the longer, more accurate z values, and then they can give you the CDF values, or vice versa. Okay, so 1 minus 0.9696 is 0.0304. So this is the probability of the type 1 error. Okay. So the probability of erroneously rejecting the claim is 0.03. Okay, part B. Suppose the population mean is 21, and we're looking for the probability of P less than equal to 20.75. Okay, so we do the same thing. We subtract mean over sigma over square root of 36, and we do the same thing to the 20.75, and we calculated that number equals to negative 0.625. Okay, less than equal, great. That's exactly the CDF. So we're looking for the CDF values of negative 0.625. Okay, either use table 3 or use some online set calculator. We get this number. The CDF values for negative 0.625 is 0.266. So this is the probability of type 2 error. The probability of erroneously accepting the claim is about 0.27. Okay, so there are actually different meanings. So about calculating type 1 error and type 2 error, do you notice that for type 1 error, what do you plug in for your mean? Well, that is the manufacturer's claim, right? So 20 is actually fixed because that is the manufacturer's claim. When you're calculating B, well, you say the claim is false. that means, okay, the population mean is not 20, but not 20, there's many choice which is not 20. Well, you can pick 21, you can pick 22, you can pick 25, you can pick 19. So that's why when you calculate part B, the type 2 error beta really depends on the mean you pick. Okay, so beta is, you can say different mu give you different values for beta. So it really depends on mu. It's a function of mu. So far, so good, everybody? Okay. Yeah, so in our example, our probability of type 1 error alpha is 0.03. When the mean, the manufacturers claim 20 minutes. Beta is 0.27 when the mean is 21, but we say the mean is false, mean is not 20, there are many choices that are not 20. So beta depending on the mu, okay? Yes, yeah, so there are infinitely many other alternatives. For each of them, there is a positive beta, and the detail is discussed in 7.8, which we're not going to cover that in our course. So in our course, we will just cover up to 7.7, and then we will go to 11.1, and that's it for our course. Okay, so I also want to make some remarks. So in this example, we are given the criterion. Okay, so the criterion in this example is like we reject the claim if the sample mean exceed 20.75, right? And we are finding the type 1 error or the type 2 error. So from now on, we will focus on the type 1 error, okay? Which is alpha. Yes. And so in the remaining sessions, okay, so in the next 2 sessions, okay, we will be given the type 1 error. Okay, we will be given the type 1 error. Okay, which is alpha, and we want to come up, so we need to come up with a criterion when to reject the claim. Okay. So this is like a decision making test of hypothesis, okay? All right, so that is 7.4. Let's continue to look at 7.5, the null hypothesis and test of hypothesis. So in 7.4, we talk about the drawing time example, okay? So we're gonna talk about more in general. So null hypothesis, H0. This is the hypothesis that is set up primarily to see whether it can be rejected. So this is like the manufacturer's claim. Okay, so manufacturer's claim, we want to test whether it is true or false. Okay? An alternative hypothesis. What is alternative hypothesis? Well, this is the claim we want to establish. It's usually the negation of the manufacturer's claim because we're trying to reject the manufacturer's claim, but not always. So usually the negation, but not always. So in the drying time example, it claimed that the drying time is 20. So if the paint dry faster, are you happy? Yeah, because it claims it's fast drying paints, right? It claims drying time is 20 minutes. If it's less than 20 minutes, if like 90 minutes, it dries faster than his claim. So we are actually happier than that, right? So that's why what make us not happy is when the mu is greater than 20. Okay, so that's why here usually I would say the alternative hypothesis is something that make you unhappy. Okay, so let me see. unhappy. Okay, think about what makes you unhappy. In the drying time example, if mu is greater than 20, then we're not happy. If mu is less than 20, or equal to 20, we are happy. Okay, so this is a one-sided alternative. Okay, so if the alternative like mu not equal to 20, so we want exactly to 20, we don't want more, we don't want less, so then this is a two-sided alternative. So far, so good. So guideline for selecting the null hypothesis. When goal of the experiments is to establish an assertion, the negation of the assertion should be taken as the null hypothesis. This assertion becomes alternative hypothesis. I would say just think about the manufacturer's claim is the null hypothesis, okay? And the alternate hypothesis is something we're not happy with, okay? So like the drying time, if the drying time is longer, we're not happy, okay? So mu greater than 20 is the one-sided alternative. And maybe you go to McDonald's and they give you a bottle of Coke, right? If let's say, what's the bottle of Coke? Is it 12 ounce? Okay, let's say it's 12 ounce. If you have more than 12 ounce, you're happy, right? You have more Coke, you're happy. So if you have less than 12 ounce, you're not happy. Then the alternative hypothesis there is mu less than 12. Okay? Or maybe we have some machine parts. We need the parts to be exactly 10 centimeters. Exactly 10 centimeters. When it's bigger than 10 centimeters or smaller than 10 centimeters, it won't fit our machine. So in that case, we need to pick a two-sided alternative. When mu is not equal to 20, we're not happy. We want exactly, when mu is 10, we're not happy. We want to the parts to be exactly 10 centimeters. Okay? All right, what is type 1 error? So type 1 error is we reject the claim when the claim is true. Type 2 error is we accept the claim when the claim is false. Okay, so when the claim is false, then H1, the alternative hypothesis, is true. Okay, so they're usually like negation of each other. So alpha is the probability of type 1 error. It's also called the level of significance. So we have another name for it. So it's the probability of type 1 error, and it's also called the level of significance. Okay, so remember that name. And beta is the probability of type 2 error, which we won't discuss in detail in our course. Okay, we mark. Alpha means we repeat the test many times with independent set of data. The long-run frequency interpretation of probability, which is the number of times the claim is falsely rejected over the number of times a test is conducted. Well, this probability is close to, this ratio is close to alpha. So this is what the alpha means, probability of type 1 error. Okay? All right, so here are the steps of test of a hypothesis. So later on, when I ask you a problem, okay, test of hypothesis. So here are the 5 steps. So in your solution, you're gonna number those steps. First steps, you're gonna formulate a null hypothesis H0. So that is usually the manufacturer's claim, and appropriate alternative hypothesis. So you think about, okay, what makes you unhappy? That is the alternative hypothesis. Okay, and that is the first step. It's good to talk about an examples when we're talking about the concepts. So in the in the drying time example, the manufacturer's claim, the null hypothesis, is mu equals to 20. And the alternative hypothesis is mu greater than 20. Okay, so this is the manufacturer's claim, and this is our intention to reject the claim. Okay, step 2, specify the type 1 error and type 2 error. So in our drying time example, our type 1 error is 0.0304, type 2 error is 0.27, but in the rest of the chapter, we will be given the type 1 error and we want to come up with the criterion. Okay, so step 3, based on the sampling distribution of appropriate statistics, construct a criterion for testing the null hypothesis. Well, what does that mean by the sampling distribution of appropriate statistics? Well, we have 3 cases: large sample, no sigma, and second case, large sample, we don't know sigma, so we use the sample standard deviation to calculate. And then the third case, we have a small sample and we don't know sigma, we use the t distribution to calculate. Okay, so those are the appropriate statistics. And construct a criterion for testing the null hypothesis. So in the next sessions, we will talk about in great details about how to construct the criterion. Okay, so in our drying time example, the criterion was given. We reject the claim if the sample mean is greater than 20.75. So that criterion was given. But in the rest of the chapter, we were gonna determine the criterion. Step 4, and then we collect the data and calculate the value on which the decision is to be based. So we collect the data and we calculate the sample mean, and the sample standard deviation, and then we look at our criterion, and then we make our decision whether or not to reject the null hypothesis, whether or not to reject the manufacturer's claim. Okay, so in our drying time examples, we record the time for 36 boards. We find the sample mean. We reject the claim if the sample mean is greater than 20.75, and we accept the claim if the sample mean is less than or equal to 20.75. So far, so good. So those are the 5 steps of the testing a hypothesis. So we will talk about more in the next session. See you soon.